Hey, good morning. Welcome to
MinuteMath138.
Math number 138. This is actually a really neat geometry problem from the Mathematical Association of America's MinuteMath page. And how much geometry have we studied? Zero. So I think this is fun just to kind of see. We know a little bit about geometry, but this is a fun one. And the problem, they said it a little bit differently, but here's what they mean. Compare the areas and the perimeters of the two quadrilaterals in the grid below. Now this grid is all the distances are supposed to be the same. It's kind of like graph paper. So we have one quadrilateral up here, we have another one down here. So let's start with the area first. Okay, so we're going to compare the area of this quadrilateral and this quadrilateral.
Well, the areas are actually pretty easy because all you have to do is... The area of a triangle is 1/2 base times height.
Okay, so the area of a triangle is 1/2 base times height.
You can cut these into triangles.
Okay, we can cut them to triangles this way and have triangle 1 and triangle 2, and maybe this one we'll call triangle 1 and triangle 2. Okay, so let's figure out the areas. All right, what do you notice about?
Well, triangle 2 is a right triangle.
Yeah.
So it's 1/2 base times height.
1/2 base times height. Okay.
And the base is 1 long, and so is the height.
All right.
So it's 1/2 of 1. The area is a half.
Okay, the area of triangle 2 here is a half.
And the area of triangle 1 over here.
Yeah. What's the base?
The base is 1.
Okay, and how tall is that triangle?
Well, it's this.
All right.
That's also 1.
That's
so
also
it's also a half.
Okay, so the area of triangle 1 plus triangle 2 here is?
1.
Okay, great.
Let me just write that down. So,
Okay, now what about this one up here?
for triangle 1, the base is 1 long.
Yeah.
And the height is 1.
Yeah.
So it's a half.
Half.
And triangle 2, the base is 1 and the height is 1.
Yeah.
So it's a half.
Okay.
So it's 1.
The area is 1. Okay.
So the areas are equal.
The areas are actually equal. It's pretty neat. You were very good idea to break it into triangles, because that's really the only thing we know, right? 1/2 base times height. So it turns out the thing I labeled as triangle 2 in both of them is actually basically exactly the same triangle, right? So it's just comparing these two, which turn out to have a base of 1 and a height of 1, so they're the same. Now what about the perimeters?
Well, the perimeter of this one is 4. 1, 2, 3, 4.
Ooh, okay. Well,
Is it or is it?
does it look we'll study this geometry a little bit later, and we have studied it a little bit with the Pythagorean theorem. Is this distance up the same as this distance diagonally? No. So if this is 1, this is not 1. But we do have 1 and then the diagonal, and 1 and then the diagonal. Okay, what can we say about, let's look at triangle 2, just the leg part of triangle 2, forget the base, just going up and across. Well, how does that compare to triangle 2 down here?
They look the same.
They do look the same, actually. They look the same. Now, can you notice anything that's the same with triangle 1 and triangle 1 down here? One of the sides in each of these triangles is actually the same.
It would be...
That is the same as what?
As this.
Okay, so we have this, and this is the same as this, and this, distance-wise. So to compare the perimeter, we only have to compare this length to this length.
And that length is 1.
This length would be 1. It's 1 unit on the grid. What about this length here? What can you say about it?
It's larger than 1.
It's larger than 1 because it goes...
Because just this distance...
It's
like about 2, actually. Maybe.
Maybe. But it's definitely longer than 1. It's because it's going across like a box. Right?
Yeah.
It's longer than 1. So, which one has the larger perimeter?
Triangle number 2 has.
Triangle number 2. So this is actually a pretty cool problem, and the area part actually hints at a really cool theorem called Pick's theorem. And the perimeter part is just, a little intuition about geometry. So we'll get there.
How many people got this one right?
About half. Half the people got this right. If you haven't studied geometry, like you,
it's a little bit
this is a very tricky problem. When you have studied geometry, not too bad. Not too bad. Not the easiest problem in the world, but not too bad. All right, good job. That's a cool problem. I like these little fun geometry problems and learning a little bit about geometry through these problems. Don't you?
Yeah.
All right, good job.